All right, guys. Today's lesson is very concentrated, a lot of emphasis on vocabulary. So, as we go through, some of you like to take notes. I've watched you do that in class, which is great. So, as we go through, if there's something I think you should make note of, if that helps you, please do so. Okay. So, how do solids and liquids change their state? Well, again, we've had a lot of this stuff. A lot of it's review. We had it back with when we did properties. Okay. So the change in state in which a liquid becomes a solid is freezing. Okay. And as we've talked, in water, that's 32 degrees Fahrenheit, and Celsius, it's 0. Okay. So when the liquid becomes a solid, the atoms gain more attraction. They want to become closer together. Just thinking, if you're outside playing, you want to like get closer, bring your arms in because you're cold. Okay, so that's what happens. So the atoms vibrate in place. Okay, and that is freezing. So it is the freezing point. Again, 32 Fahrenheit, 0 Celsius. So again, if you want to not jot that down, freezing is when a liquid becomes a solid. All right, so let's look at these questions here. First, with number 9, in which sample of water do the water particles have more energy? 5 grams of ice cubes at negative 10 Celsius or 5 grams of liquid at 20? And how do you know? So where would the particles have more energy? Well, the one that is warmer, okay, more heat. So the water at 20 degrees Celsius have more energy because the particles have more energy than the particles in the solid. Okay. And then down here, write the state of the substance shown. So we have this and we have this. Solids can change to liquids, liquids can change to solids. So what do we think A is? Say it at home. I hope you said solid, and that means B is a liquid. Okay. And again, something you need to memorize, freezing point of water is 0 Celsius, 32 Fahrenheit. Okay. So that is very important. Okay. Now, the opposite of that is melting, a solid turning into a liquid. And when that happens, the atoms lose some of their attraction and start sliding past each other. Back to our movie theater example. We've left the movie theater and we're out in the lobby. Okay. And the temperature where that happens is called the melting point. Okay. So I want you to think about something and then we'll talk about it in a second. So let's talk about what happens to water particles when ice melts. Okay. So the particles in the ice, when it melts, what happens? They're going to gain energy. Okay. The particles start moving faster. So that attraction that keeps them all together is going to be broken. So they slide past each other. Again, just like I said before, we're moving from the movie theater out into the lobby. All right. This is where some people get confused throughout the years. The freezing point and the melting point of water are the same. Okay. So it says, explain why a substance like water freezes and melts at the same temperature. So why would that be? Why would it be the same point where ice becomes water and water becomes ice? That's a great question. You're probably going to see that again at some point. All right. It's because they're what's called reverse processes. So if energy is added at 0 Celsius, 32 Fahrenheit, the ice is going to melt. Okay. If energy is removed at 32 Fahrenheit, then the water is going to freeze. Okay. Now, how do they change state? Gases being the key difference here. All right. Gases already have a lot of energy. So getting them to change state requires the removal of a lot of that energy. Okay. This is a word that you've maybe not heard. This would be another definition type word that you need to pay attention to if you're a note taker. The process by which a liquid or solid changes to a gas is called vaporization. Okay, vaporization. And I'm sure you've probably heard this one. This is another very important vocabulary word. The process by which a liquid's particles can escape from the surface, think water, through heating is evaporation. Okay, it occurs very slowly at a range of temperatures, but obviously the higher the temperature, the more quickly it would happen. And to have a rapid change, that's called boiling. So if you've ever been in the kitchen with parents, sisters, brothers, grandparents, whatever, and you see them boil water and it starts bubbling, that's what we're talking about here. And there is a great picture of it. All right. As air pressure changes at different elevations above sea level, so does the boiling point. We talked about this in IXL. Okay. So the greater the air pressure, the higher the boiling point. So, any of you are like football fans or ski or anything have been to Colorado, like the Denver Broncos football team, Denver Nuggets basketball. Denver is very high up. Okay. It's a mile high off of sea level. Okay. So they would have different numbers there. All right. So if we look at these questions, what would happen to the boiling point of water at 8,000 meters above sea level where air pressure is lower? Well, okay, it would be less because there's less air pressure. All right, so this question here is similar to one we just had. Okay, liquids can change to gases and gases to liquids. Well, box A would be, I hope we know this, a liquid, and box B would be the gas. Again, boiling point of water is 100 Celsius, 212 Fahrenheit. Okay. Particles in a gas have very little attraction. Remember, it's us outside of the movie theater. So people are but people are able to move wherever they want once they get out into the parking lot. Well, that's what the particles are flying all over the place. So when we take energy away and the gas goes to a liquid, that is called condensation, the exact opposite of evaporation. Condensation is like when you see water on windows. All right. So let's look here. Indicate whether the change of state in each process causes the particles to have more freedom to move about or less. So more freedom would be an A, less freedom would be a B. Okay. So melting of ice. Are the particles going to have more freedom to move or less? Well, they would have more because in the ice, they have less freedom. They're a solid. Remember, they're just vibrating in place. How about boiling? So we're going from a liquid, theater lobby, to a gas, anywhere you want to go. So that would be more freedom. All right. Now we're condensing. We're taking that gas and bringing it back down to a liquid. So that would be less freedom. All right. We're going to actually skip that question. We're going to talk about it later. Okay. We've had this word a little bit on IXL, but I want to reinforce it today because you're going to have questions about it. In some conditions, solids and gases never are a liquid. They go straight from a gas to a solid or straight from a solid to a gas. Okay? And obviously, they have to lose a great deal of energy for that to happen. So if it goes straight from a solid, dry ice, to a gas, that is called sublimation. And again, we had that on one of the IXL videos. If you watched it, do your IXL. All right. So again, here's the dry ice example, and it doesn't ever become a liquid? Well, oh, we have a video. We're not going to watch that video today. It'll probably be in our work either Tuesday, probably Tuesday. Okay. Now, going the other way, the opposite from gas to a solid is called deposition or resublimation. Another important video, definition. Okay. So deposition can occur when invisible water vapor turns into ice crystals on a cold window. Hopefully we'll have some of that soon. I love the winter. Okay. So let's look at, we have two questions here. Number one, explain how sublimation and deposition are alike and how they are different. Think about how they're alike. What happens in both of them? I hope you said that liquids, they're never a liquid. They're only solid and gases are involved. Okay. And they're different because one is solid to gas, the other one is gas to solid. All right. This is a great chart, and you are going to see this after Thanksgiving for sure. Okay. So what you want to do is complete column 1 and column 2 to identify the opposite processes. And the third one, indicate if it's a result of gain or energy or loss. Okay. So the opposite of deposition is sublimation. And would that be a gain? Complete content. There we go. Oh, column 2. Where gains the energy? Sorry, I wasn't reading it right. You guys can laugh at me. Okay. So the sublimation is where the energy is gained. Okay. What is the opposite of condensation? Okay. Condensation is when water develops like on windows and stuff. Well, the opposite of that would be evaporation, water turning into vapor. Again, the energy is gained there in column 1. Okay, they saved the easiest for last. The opposite of melting is freezing. And which one do the particles gain energy? Well, in the melting. All right, if you need to watch this again and go back through any word that was kind of highlighted, because your work for today is simply questions with definitions, okay? You may do it as many times as you want to get the grade you want, but we need to know those definitions, okay? All right, work on IXL. Take care.